Hi, my name is Walter Oliveira. Today I'm going to show you how to deal with one of the most common troubles that students have when facing the task of doing a double integral. One of the main problems when students try to solve such exercise is how can we translate the region D. So you have there in a space a region D. How can you translate this region D in limits of integration in an integral? For example, you have here the integral of this region here, defining in this region here of, let's say, a function f of x, y, dA. How can you solve this? How can you translate this d here into something like this: x1 to x2, y1 to y2, for example, f dy dx, for example. How can you do that? How can you find these constants or these functions here? So I will show you. The first step you need to do is you draw a Cartesian plane. So here I have a Cartesian plane, and you draw your region D. So in this exercise, the region D is limited by the parabola, by these two parabolas. So let's draw these two parabolas. So I will change color here. I will do it first in yellow. So I will have a yellow parabola and a blue parabola. So I will take some values here. So I will take 0, plus or minus 1, plus or minus 2, because as both parabolas, the x is square, so it doesn't matter the sign, okay? So when x is 0, 2x squared will be 2 times 0, will be 0. When x is plus or minus, okay, 1, 2x squared will be 2. And when x is plus or less 2, 2x squared will be 8. X squared will be 4, 2 times it will be 8. So let's put all of this point here on the graphic. So first point, 0, 0. Here is 0, 0 is the first point. Second point, 1 and 2. So I will say that 1 is here. So here is 2. Let's just put it here, 1, and here is 2. I will just keep trying to keep the same size here, okay? And here will be minus 1, minus 2. And here in this y-axis, I will look here and see the greater value that I have here is 8. So let's say 8 is here. So the scale doesn't matter too much to me because I'm just sketching the graphic, and it doesn't matter for me that the scale on this axis is different from the scale on this axis, okay? That doesn't matter. So if this here is 8, half of the path here is 4. Half of it again is 2. And half of 2 here is 1. So here for me in this y-axis, the unit has the size, while in the x-axis the unit has a greater size. That doesn't matter, okay? So let's do what matters here is that we have to connect the dots properly. So 1 is connected with 2 here, minus 1 as well is connected with 2 here. So I have this point, I have this point, I have this point, and plus and minus 2 is connected with 8. So let me make this connection here. so here, and as well here, so about here. So the this parabola 2x squared, just connecting here the dots, will be this parabola right here. Let me try here to do its graphic. Okay, more or less. So here is the y equals to, let me just put here this here, this is, let me put just 2x squared. That's great. So now let's move in and draw the other parabola. So I will change color for that. I will take here a blue color. So let me take the color blue here, and let's do the table here again. So for the blue parabola, we have, let me just draw here a table for it. So x, y, I will put the same values again for x, 0 plus or less 1 plus or less 2. When x is 0, so x squared will be 0 plus 1, y will be 1. When x squared, when x is plus or minus 1, this here will be 1 plus 1, this will be 2, y will be 2. And when x is 2, no matter the sign, this here will be 4 plus 1 will be 5. So 1 will be 5. So let's connect the dots here. 0 is connected to 1 here. 1 is connected with 2. So 1 with 2. The same point here as the yellow is an intersection. And minus 1 also here connected with 2. 2, positive 2 is connected with 5. Let me draw 5 here. Between 8 and 4, half of the path here, I have exactly the number 6. And between 6 and 4, in the middle here, I have 5. So here is 5. I will connect it with 2. Also with minus 2. So I have here the dots. Let's connect the dots. So here, connecting the dots for the blue parabola. Let me just make the same thing here for the left side. So here it is, more or less here the graphic, the sketch of the graphic of this blue parabola, which is this one. Let me just put here the equation 1 plus x squared. This is that parabola. So now let's see what is the region. What is the region D that the exercise are telling us. So let me just pick another color here, which I will use red here. I will paint here in the draw which the region D is. Excuse me, let me just pick here the color, the paint. So here it is. This red region here. This red region here is the region D, the region D on the exercise. Once we have found the region D, we can written it in a algebraically form. So let's do that. So D, just a minute here, or just change here again. D is equals to the set of all x and y points, okay, belonging to R square, the plane, all points that is on the plane, such that x is ranging here, actually is changing from -1 to 1, and y is let me just resize resize this picture here in order to gain more space here. Okay, now let's continue. Ny is from the function 2x squared to the parabola 1 plus x squared. So it was important that we have drawn the graphic to see this, because the blue parabola is above the yellow parabola, just between -1 and 1. Outside this interval, that is not true, and that is essential for us to solve the integral. See, the integral will become the following. The integral of that region of the function will be equals to the integral when x is from -1 to 1, and when y is from 2x squared to 1x plus x squared. See, it's essential to know which function comes above, which function comes below, and the graphic has helped us to see that. And f of x here I will substitute by x plus 2y, which is the expression for f, and dA is just dy dx, because we are going to solve for y first. We are going to solve for y first and for x later. So that was the video that I have planned to show you today. The goal here was just to show you how you find this limit of integration here that we have found. And if you intend that try to solve this integral here, because for now it's just an exercise of calculus 1, okay? So, but if you want to see the entire solution for this problem, you can let me a comment, and I can post another video just solving this integral here, okay? So see you in another video or in online classes. So till the next time, bye.